students, welcome to the video lecture series of Digital Fundamentals. I am your instructor Farnaz Patel, and in the continuation of module 2, which is combinational digital circuit, today we'll learn QM method and MEV method for Boolean expression simplification. So today we'll be covering disadvantage of K-map, QM minimization technique, and MEV method. So what are disadvantages of K-map? So there are some combinational circuit with a large number of input. So the simplification using K-map becomes very difficult for variables greater than 6. Also, the K-map is manual technique, so we cannot implement using computers. So to overcome these disadvantages, other methods can be used. First method is Quine-Mac-Kluske minimization technique. So here it can be used as Boolean expression minimization. So in this QM method, we have two important terms which are prime implicant and essential prime implicant. So prime implicant is the group of mean terms which cannot be combined with any other mean term or groups. And essential prime implicant is a prime implicant in which one or more mean terms are unique. In other words, it contains at least one mean term which is not contained in any other prime implicant. So we'll understand the meaning of PI and EPI with the help of example. So this is given example. Here for 4 variables which are W, X, Y, Z, we have given 1, 4, 6, 7, 8, 9, 10, 11 and 15 mean terms. So first step is we have to write down the binary format of each mean term. So here we can see that I have written binary format for each mean term. So for 1 it will be 0, 0, 0, 1. For 4 it will be 0, 1, 0, 0 and so on. Now we have to count the number of ones in each term. So for mean term 1, number of ones is 1. For mean term 4, number of ones is 1. For mean term 6, number of ones are 2. And same for all other mean terms. So for mean term 15, the number of ones are 4. Next step is we have to group them. So we group them by the number of ones. So if there is 0 number of ones, we will make a group of 0. But there is no 0 number of ones present. So we will start with the group 1. So M1, M4 and M8 contains 1 number of ones. Now group 2 includes M6, M9 and M10. So this group have 2 number of ones. Same for 3 number of ones and 4 number of ones. So 3 includes M7 and M11 and group 4 includes M15. Now next step is we have to compare group 1 and group 2, group 2 and group 3 and group 3 and group 4. So we have to compare each mean term. So first for group 1 and 2, mean term 1 and mean term 6 will be compared. Then mean term 1 and mean term 9, and then mean term 1 and mean term 10, then mean term 4 and mean term 6, then mean term 4 and mean term 9, and then mean term 4 and mean term 10. Now we have to notice the 1 bit change. So we have to write down the mean terms where there is 1 bit change. So we can see that for M1 and M6, W is same, X is different, Y is different, and Z is different. So here we don't have. So here more than 1 number of bits are changing. So we have to compare another one, M1 and M9. So here we see that W is changing, X is same, Y is same and Z is same. So this term will be included in the next table. So M1 and M9 will be included in the next table. Now we have to mark dash in the place of changing bit. So here W is changing. So we have to mark dash in the place of W. So let's see the next table. Here M1 and M9 will be dash 0, 0, 1 because W bit is changing. Same for M4 and M6. Y bit is changing and every other bit is same. Same for M8 and M9, Z bit is changing, and M8 and M10, Y bit is changing. Next, we have to compare group 2 and group 3. So for group 2 and group 3, M6 and M7 is possible group. So here Z bit is changing. M9 and M11, Y bit is changing, and M10 and M11, Z bit is changing. For group next, we have to compare group 3 and group 4. So here M7 and M15, W bit is changing, and M11 and M15, X bit is changing. Next, we have to mark all those terms which are covered in the next table. So all of these terms are covered in the next table. So in this table, no prime implicants are present. Next step is again to compare group 1 and group 2, group 2 and group 3. So we have to compare each term from group 1 with group 2. So here we notice that M8, M9, M10 and M11 includes one bit change, which is Y bit, and M8, M10, M9 and M11 includes one bit change, which is Z bit. Now we have to mark all the terms which are covered in the next table. So we have M8 and M9, M8 and M10, M9 and M11, and M10 and M11 covered. All of the terms except these terms are prime implicants. So we will include them into the prime implicant table, which are M1, M9, M4, M6, M6, M7, M7, M15, and M11, M15. Now, no further grouping is possible because there is no one bit change. So this both term will be R prime implicant. This both term will be added to the prime implicant table, but these terms are same because it includes 8, 9, 10 and 11. So we will include one of them into the prime implicant table. Next step is to write down all the mean terms in the prime implicant table which are given in the question. Next, we have to write down the groups which are prime implicants. So the prime implicants which are non-marked term are 1, 9, 4, 6, 6, 7, 7, 15, 11, 15 and 8, 9, 10, 11. Now we have to mark the 1 and 9 as cross, 4 and 6 as cross, 6 and 7 as cross, and same for all other terms. Now we have to check that which column includes single cross mark. So we have to circle that column. So we can see that one mean term 4, 8 and 10 includes single cross mark. So we will circle them. Now those rows which have circle present will be marked. So X bar, Y bar, Z, W bar, X, Z bar and W, X bar will be marked. So these three terms will be our essential prime implicant. So these terms include 1, 9, 4, 6, 8, 9, 10 and 11. Two terms from this table are still remaining, which are 7 and 15. So we have to find a combination which includes 7 and 15. If they are in the separate mean terms or separate group, we have to consider those both group. But here we can see that these two terms are included in this single group. So we will consider this group. And our answer will be x bar y bar z plus w bar x z bar plus x y z plus w x bar. Next is map entered variable, which is MEV or VEM method. In MEV K-map, it is allowed to enter single variable or an expression in the cell. So, for example, we have given three variables A, B, and C, which includes mean terms 0, 1, 4, 5, and 7. So, we will write down the truth table for it. So, we will mark 1 as an output for the given terms. So, 0 term will be 1, 1 term's output will be 1, 4th output will be 1, 5th output will be 1, and 7th output will be 1. Next, we will consider C input as an MEV. So, next step is to consider C input as an MEV. Now we can see that for input AB, first and second term, which is 0, 0, is same. So, we will group them. Same for second term, which is 0, 1. Third term, which is 1, 0, and fourth term, which is 1, 1. Now, same we will make group of 2 for the output. There is a rule that if the combination is 1, 1, we will take it as 1. Combination is 0, 0, we will take it as 0. Combination is 1, 1, we will take it as 1. And combination is 0, 1, we will take it as C. If the combination is 1, 0, we will take it as C bar. So we will fill this output in this two variable K-map. So 0th term will be 1, first term will be 0, second term will be 1, and third term will be C. Now we have to make the pair or chords or octet possible. Now we have to combine ones and variables. So there are two pairs possible. One, this pair, and this pair. So the answer of it is B bar plus A C. So this is our simplified Boolean expression for given mean term. Here is the end of the simplification of Boolean expression using various methods. From next class, we will see the multiplexer and demultiplexer circuits. Thank you.